Hello students, today we will start chapter number 5 in mathematics paper 2nd, application of definite integration. The chapter weightage of the chapter in HSC examination is only 4 mark, and the points contained in the chapters are only 2 points: the area bounded by the curve, axis and the given line, and second is the area between two curves. Now first point, the area under the curve. Now y is equal to f of x is continuous function in closed interval ab, and f of x is greater than or equal to 0 in closed interval ab. That means this value of function is positive in closed interval ab. Then we find the area of this curve, bounded area of this curve with x-axis and these two lines. Suppose this line x is equal to b, and equation of this line is x is equal to a. That means this distance is a and this distance is b. Therefore the x is equal to b is the equation of QS, and x is equal to a is the equation of PR. Then the area A bounded by this curve is integration from, here start lower limit, the value is A, to upper limit B, f of x dx, that is area A to B y dx. Y is equal to f of x is the continuous function. By using fundamental principle, solve the integration and substitute upper limit minus lower limit. We get the integration of, we get the area bounded the curve y is equal to f of x, x-axis, as well as the line between x is equal to a and x is equal to b. Now suppose the x is equal to g of y is the function which is also continuous in closed interval CD. That is g of y is greater than or equal to 0 in closed interval CD. That is, we write this, the equation of PR is y is equal to C and QS is y is equal to D. Then we find the area. Here the function in terms of y, not in terms of x. Therefore area is equal to integration of g of y with respect to y dy, that is, and limit is, the line area lies between these two lines as well as the y axis. The limit is c to d. Then after solving integration by using fundamental principle, upper limit minus lower limit, we get the value of area bounded by this curve, two lines and y-axis. Now in this way there are two types: the area bounded by two lines and y-axis, area bounded by two lines with x-axis. And next point is, second point is area between two curves. The second point is area between two curves. Now here we take y is equal to g of x is the one of the curve and y is equal to f of x is the other curve. Now the intersection points, these are the R and S. Draw RP as well as SQ perpendicular. Suppose this distance from origin to point P is A and distance from origin to point Q is B. That means the equation of this line is x is equal to A and equation of this line x is equal to b. Now we want to area bounded these two curve. That means this shaded portion, area of shaded portion, suppose we write A, and there are two areas, that is A1 area bounded by curve y is equal to f of x, x is equal to a, x is equal to b, and x-axis, and A2 is area bounded by curve y is equal to g of x, x is equal to a, this is one of line, x is equal to b, and x-axis. These are two areas. That means first area is this form, second area, which is a A2, whole area is A1, and we want to only A. That means area A is equal to A1 minus A2. We draw the nature of the figure. That means the greatest area is A1, therefore we take first greatest area. Lowest area is A2. But we cannot draw the figure, then we take the modulus sign, mod of A1 minus A2. Area bounded by the first curve minus area bounded by second curve. And suppose its value is negative, take modulus sign, area is always positive. That means area between two curves can be found in this way. A is equal to A1 minus A2 is equal to mod of A1 is integration of A to B, function is y is equal to f of x dx. Suppose we take here y1 and y2 minus integration of, limit is same, a to b, g of x dx is equal to integration of a to b y1 dx minus integration of a to b y2 dx. In this way we find area bounded by two curve. Now these are the theoretical part, these 2 points most important, area between two curves as well as area between the line as x-axis, curve and x-axis, curve and y-axis, line and x-axis. Now we solve some problems. Now first problem is find the area of the region, find the area of the region bounded by the curve y is equal to 2x, x is equal to 0 and x is equal to 5. Now y is equal to 2x is the equation of straight line. The constant term is absent, therefore line is passing through origin. So we here draw the line y is equal to 2x. Then the x is equal to 0 and x is equal to 5. The x is equal to 0 is the equation of y-axis, that means this point, and x is equal to 5. Now this line x is equal to 5 parallel to the y-axis. That means we find the area bounded by this line y is equal to 2x lies between starting from origin, that is x is equal to 0, and the line x is equal to 5, which is a shaded area. We find this area. The formula is area is equal to y dx a to b. A is called as the lower limit, b is called as the upper limit. Now the lower limit is 0, 0 from 5, and the value of y is 2x with respect to x is equal to, the integration of twice x is 2x square divided by 2, lower limit 0, upper limit 5, 2 to cancel, x square 0 to 5, that is 5 square minus 0 square. 5 square is 25 minus 0, 25 square unit. The area of curve y is equal to line. Here actually which is not curve, but common question is find the region, find the area of the region bounded by the curve. This is the actually line. Y is equal to 2x passing through the origin. X is equal to 0 and x is equal to 5. This is the answer. Now the second example is x is equal to 2y, y is equal to 0, y is equal to 4. Now the line is x is equal to 2y, which is also passing through the origin. But the y is equal to 0 is the equation of x-axis starting point, and y is equal to 4. This is the line y is equal to 4. That means we want to this shaded portion. Then area is equal to, here the function is x is equal to twice y. Therefore we write x dy limit from c to d or a to b. We apply the second formula. So we study the second formula is now this is the second formula, g of y dy c to d. G of y is equal to x is equal to twice y, that means the function in terms of y. Then the area A is equal to, limit is 0 to 4, x is equal to 2y dy is equal to, integration is 2y square divided by 2, y square divided by 2, limit 0 to 4, 2 to cancel, 4 square minus 0 square, that is 16 minus 0 is equal to 16 square unit is the area of this curve. Now take next example, third example. Xy is equal to 2, x is equal to 1 and x is equal to 4. Find the area of region bounded by this curve. Xy is equal to 2, x is equal to 1 is the line, second line is x is equal to 4. Now first write this equation in terms of x or y. We write first equation, y is equal to 2 divided by x. and the limit or the line are x is equal to 1 and x is equal to 4. Now y is equal to 2 divided by x is the function in terms of x, y is the function in terms of x. Therefore, area A is equal to, we cannot draw the graph of each functions easily. Here 1 divided by x, the nature of graph as x increases, y is decreases. If we take x is negative, then y is increases. But only by applying fundamental theorem, area is equal to a to b y dx is equal to a is x is equal to 1, x is equal to 4, y is 2 by x dx is equal to, the integration of 1 by x is log x, 2 into log x, lower limit 1, upper limit 4. Therefore, 2 log 4 minus 2 log 1, that is 2 log 4 minus log 1 is 0, 2 into 0 is equal to 2 into log 4 is the final answer. Or we write 2 into log 4 is 2 square by using rule of logarithm. 2 into 2 is 4 log 2, which is also correct answer. This is also correct answer. Now it is a very simple example. And next example, fourth example. X is equal to 5, y is equal to 4, x is equal to 0 and y is equal to 0. That means x-axis and y-axis as well as x is equal to 5, y is equal to 4. Now the x is equal to 5 is the line parallel to y-axis, y is equal to 4 is the line parallel to x-axis, x is equal to 0 is equation of y-axis, y is equal to 0 is equation of x-axis. We draw the rough nature, that is y-axis, x-axis, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. Now x is equal, y is equal to 4. Y is equal to 4 is the line parallel to y is equal to 4. And x is equal to 5. X is equal to 5. So this is the shaded portion. Now the distance from origin to, suppose O, P, Q, R. Now O, P, Q, R is the rectangle. The distance OP is 5 and distance PQ is 4. The area of rectangle is width into height, that is 5 into 4, 20 square units. But we apply the application of definite integration. Now first, there are many methods to find. First method is to find area y dx a to b. The y is equal to 4 and y is equal to 4 dx. The limit is, we take y is equal to 4, therefore take limit from 0 to, on y axis 0 to 5. Y, if we take y dx, then we take the limit x is equal to 0, start from 0 to that line, that is 5. Then 4x 0 to 5, 20 minus 0, 20 square unit. Now second point, some students can take area is equal to a to b x dy. Then we take 5 dy, the limit from 0 to 4, 0 to 4, this 0 to 4. Then we get 5y 0 to 4 is equal to 5 into 4 minus 0, 20 square units. Now third method is we find the equation of line passing through origin and that point, that is the diagonal. Now by using 2-point form, find its equation, then find the area bounded by this line. Suppose this area is 10 and another area is also 10, 10 plus 10 is 20. In this way third method is also can be applied. Answer is same. Now we verify that the area under the curve by using the integration is correct, because here which is the area of the rectangle, by using basic formula height into width, its area is 20. Its area is 20. Also by using integration bounded by the line y is equal to 4, again its area is 20. Bounded by x is equal to 5, then again its area is 20. Again we apply this form, again area is 20. So in this way we solve some problems. Now we take one more example. Next example, y is equal to sin x, limit x is equal to 0 and x is equal to pi by 2. Now we draw the rough nature. Here pi by 2, its value is 1, 0, then value of pi is 0. Now continue this process. We want to area bounded by the curve y is equal to sin x and limit is 0 to pi by 2. Then its area is a is equal to integration of y dx, limit from a to b is equal to limit is 0 pi by 2 sin x dx. The integration of sin x is minus cos x 0 to pi by 2. Substitute the value, minus cos of pi by 2 upper limit minus cos of 0 is equal to cos pi by 2 is 0 minus of cos 0 is 1 minus minus plus square unit. Now which is the fifth example, area bounded by curve sin x, limit from 0 to pi by 2. If you ask 0 to pi, then this area, or we write directly this area is also same, twice pi, twice 1 plus 1 is 2. Now next example, y square is equal to 16x, x is equal to 0 and x is equal to 4. Now the curve is y square is equal to 16x. Comparing this curve, y square is equal to 4x, which is the equation of parabola. That means the nature of this curve is in this way. Y square is equal to 16x. Last year, conic section, we studied the ellipse, parabola, hyperbola as well as circle, conic section. And the area bounded by start from 0 to x is equal to 4. That is, suppose x is equal to 4. That means we find the area, this shaded portion. 0, here 4, x-axis, y-axis. Now we find the area, this point O, suppose P, Q, and this R. O, R, P, Q. But first we find the area bounded by this curve with x-axis. That means area OPQ, and the area below the x-axis is equal area. Then we take its sum, that is A1 plus A2, or twice area of required area is equal to twice area of region OPQ. Therefore, area is equal to twice integration A to B y dx is equal to twice integration, lower limit is 0, 4. The value of y square is equal to 16x, but we want only y, then y is 4 root x dx. Now here to write, because we want to total area, not find separately A1 and A2, twice area of A1, which is the area A, required area, is equal to twice the into 4 integration of 0 to 4 root x dx is equal to 8. The integration of root x is x raised to half. Its integration is plus 1 divided by 1 by 2 plus 1, that is x raised to 3 by 2 divided by 3 by 2. Therefore, is equal to 8 into 2 is 16 divided by root 3, and the value of lower limit is 0, upper limit is 4. 4 raised to 3 by 2 minus 0 raised to 3 by 2 is equal to 16 divided by root 3 into 4 raised to 3 by 2, that is 2 square raised to 3 by 2 minus 0 is equal to 16 divided by root 3 is 2 to cancel, 2 cube is 8. Therefore, its value is 8 into 16, 128. Its product is 128 divided by root 3 square unit, which is the area bounded by this curve, total area. In this way, we find area bounded by the curve parabola y square is equal to 16, and the limit is 0, that is origin, to x is equal to 4. First, only find the area in first quadrant, The curve is symmetric, therefore this area is equal. Okay, next period we solve some complicated example in this article. Okay.